Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss the sequential container. For example, vector. So what is a sequential container? It is the container used to store the element in the sequential order. The implementation data structure which can be accessed in the sequential manner. For example, vector, list, DQ, arrays. We'll discuss one by one. First, we'll start with the vector. So, what is the vector? It is similar to dynamic array with ability to automatically resize itself when the element are inserted or deleted. The element in a vector are stored in the continuous memory location, which allow the efficient access and travels using the iterator or indexing. The vector typically insert the element at the end using the pushback functions. What is the time complexity for inserting element and deletion element? While inserting element at the end and deletion element at the end, the time is constant. But the insertion, deletion, the element at the beginning or middle, that cases the time is linear because the element need to be shifted. And next one is functions that is associated with the vectors. So here there are four categories there: iterators, capacity, element access, and modifiers. We'll discuss one by one with an example. First, we'll start with the iterators. So it has some of the inbuilt functions. For example, begin. So it will return on the iterator the pointing to the first element. And next one is a n. It will return the iterator the pointing to the just after the last element. And next one is a or begin. It will return the reverse iterator which will point to the last element. And next one is a or n. It will return the reverse iterator which will point to before the first element. And next one is a c begin. It will return the constant iterator. It will point to the first element. And next one is a cn. It will return the constant iterator that will point to the position just after the last element of the container. And next one is c or begin. It will return the constant reverse iterator which will point to the last element of the vectors. Then c or n. It will return the constant reverse iterator that point to the position just before the first element of the container. We will see one example using the functions. For example, here we are creating the object from the vector. This belongs to the integer. So now we are going to push the value into the vector using pushback functions. For example, here we are using the for loop. The for loop it will rotate 5 times. So every time it will get the values. The value we are going to push back into the vectors. For example, first the 1 it is inserted in the loss. Again the next value insert in the loss, and next insert at loss, at insert loss, and last again it is insert in the loss. Like that we are going to insert the value in the backside of the vector. So if you want to see the result or the content of the vector, so here we are using the for loop. So here the for loop, the g1 dot begin mean the pointer is point to the first. Then next one is then we are going to verify till the end of the vector is empty or not. So if content is there, then it will print. So like that the for loop is rotated. Every rotation it will get the inputs from the vector, then it will show that. And next one is the output of the c begin and cn. So here similarly here we are using the for loop. Now we are using c begin and we are going to verify till end of the vector. Then we are going to increment. We are going to get the value from the vector. Then we are going to display. For example, 1, 2, 3, 4, 5, because already only the 5 value is that is insert in the vector, right? It will show the same result. And next one is we are going to show the output of the or begin and or end functions. So now the for loop start with or begin. We are going to verify till r1.n. So or begin means what? So it will start from the end. Then automatically it will from the reverse order, right? Because or begin. So start from the end, then till it will the control is moved to the beginning. First the 5 it will print, then 4 it will print, then 3, then 2 and 1. And next the output of the CR begin and the CR end, they will show the same result because we are going to start from the end of the vectors till we are going to move towards the beginning of the vectors. And next one is the capacity. The capacity has some of the inbuilt functions. For example, size. It will return the number of element in the vector. And next one is the max size. It will return the maximum number of element that the vector can hold. And next one is the capacity. It will return the size of the storage space currently allocated to the vector. And next one is the resize. If you want to resize the capacity, then we can change it. And next one is empty. Here we are going to verify whether the container is empty or not. And next one is string to fit. Then we are going to reduce the capacity of the container to fit its size and destroy all the element beyond the capacity. And reserve. So here recovers to the vector to allocate the memory at least n elements. I will see some example program using the functions. So for example, here the object is created from the vector. So now we are going to reserve the memory space. So now here 8. So now 8 memory space is allocated. See 1, 2, 3, 4, 5, 6, 7, 8 memory space is allocated. Then we are going to push the value into the memory location of that is the vector memory location. So now the loop is 5 times it will rotate. Every time it will get the I value. Then we are going to push the value in the vector. For example, 1, 2, 3, 4 and 5. Now we are going to call some inbuilt function. Then we will see the result. For example, g1.size. So g1.size means what? How many element within the vectors? 1, 2, 3, 4, 5 element, right? The result is 5. And next one, G1 dot capacity. Capacity means that is the reserved space. How much memory space is reserved here? So here 8 memory space is reserved. And next one is G1 dot max size. So then it will tell the maximum size. And next one is if you want to resize, then we can do it. So now we are going to reduce the memory space. For example, resize is 4. So automatically the 1, 2, 3 and 4 up to the memory space is removed or destroyed. So now after destroying up to this, now we can see the G1 dot size means what? Only the 4 element because up to this the element is removed. And next one is G1 dot capacity, but already reserved capacity is for 8, right? That it will display. See, but temporarily we are going to resizing here, but actually the allocated memory space is 8, then it will display. Now we are going to verify whether the vector is empty or not, because already some other content already exists in the vector, right? So it will show that the vector is not empty. Now we are going to reduce the memory space. We are going to fit according to the inputs. So here the input is only 1, 2, 3, 4, right? Because already resizing is 4, right? Here only the 4 element. According to 4 element, so we are going to reduce the memory space. We are going to fit according to the input. So now the remaining all the element and space will be destroyed completely. So up to this destroyed. So what is the value right now? So now 1, 2, 3, 4. What is the capacity? Now 4. And next one is the element access. The element access, it has some of the inbuilt functions. For example, reference operator. So it will return the reference to the element at the position G in the vector. But here there is no bound checking. So next one is the at G. It will show the same result, but the difference, it will perform the bound checking. And next one is the front. It will return the reference to the first element the vector. And next function back, it will return the reference to the last element in the vector. And next one is the data. It will return the pointer to underline the array. We'll see the example using the functions. For example, the object is created from a vector. Now we are going to push the value 10 times. So first get the I value. The I value is multiplied with the 10. We are going to push back in the vector. So the for loop is 10 times rotated. Every time we are using the formula, then we are going to multiply. Then we are going to insert the value in the vector. So we are going to insert like that. And next, if you want to see the content of the vector, so we can use the for loop. So here the for loop, we are going to start with the beginning. We are going to verify till the end of the vector. Then we are every time it will get the value from the vectors, then it will show that. And next we are going to use the functions. For example, g1.2. It means what is the second position of the value. See, what is the second position of the value? 30. That will be print. And at 4, it means what is the fourth location of the values. The fourth location of value is 50. That will be print here. Already told you, right? Both are the same result. The operator and then at both it will show the same result. And next one is g1.front. What is the front value? 10. Then g1.back. What is the last value in the vector? 100. That will be print. Then g1.data, it is stored in the pointer variable. So now we are going to print the point position variable. So now automatically it will start with the first value. The value is 10. And next one is we will take a new input. The vector it has 1, 2. The second vector it has 3, 4. Now we are applying the swap operation. v1 dot swap v2. So what will happen? Ultimately the content of v2 it is moved to v1. The content of v1 it will move to the v2. So now we will verify the result of v1. So now 3, 4 and 1, 2. Thank you.